All right, we're going to play a game, and that game is called Can You Guess the Temperature? So this game is going to test your knowledge about phase change and temperature and how that relates to real-life applications. So without further ado, let's get started. First, we have the icy beaker. So beaker A, B, and C all contain 1,000 milliliters of water, but beaker A has about 800 milliliters of ice, and the rest filled with water. Beaker B has 500 milliliters of ice, and beaker C has only 200 milliliters of ice. And again, all of those are filled with water the remainder of the way. So my question for you is, which beaker is the lowest in temperature? And actually, I'm going to want you to take it one step further. I want you to rank these from lowest temperature to highest temperature. Write down your predictions now. All right, I didn't give you the full 30-second Jeopardy countdown, but I gave you, I think, enough time. So let's now go to our next question, because of course I would not give you the answer right away. I'm going to ask you something different. I'm going to ask you about hot beakers now. So beaker A, B, and C are all filled with 1,000 milliliters of water again, but beaker A has been on the hot plate and has just started boiling. We'll say it's been boiling for about 5 minutes. Beaker B has been boiling for about 30 minutes, and beaker C has been boiling for over an hour. So if I took the temperature of these beakers, which beaker would be the highest in temperature? And I want you actually to rank these from highest temperature to lowest temperature. Go. All right, so now, are we ready to see if you are correct? So, how confident are you? Do you think you know? Let's see. Okay, so first we'll start off with the icy beakers. So the icy beakers are all the same. Believe it or not, no matter if you have mostly ice or mostly water, as long as all of the contents in that beaker are in thermal equilibrium, then they're all the same, and they're actually all 0 degrees. So 4 ice cubes or 40 ice cubes in your ice water does not make a difference. It is all going to be 0 degrees, which is pretty crazy. Most people don't know this or understand why this is. So now the last question we had was hot beakers, and these guys are all the same. So now we have boiling water, and we have the liquid and gas phases, right? And so when we have those liquid and gas phases, there is no way that that can go over 100 degrees. So when I'm boiling water, if it's for 5 minutes, 5 hours, or 5 days, it will never increase over 100 degrees Celsius as long as the liquid and gas phase are both present. So this seems a little weird, not going to lie. Why is this? Well, what you're going to do is you're going to start uncovering what the molecules are doing, because that's what we need to do, is we need to understand the behavior of the molecules to explain this phenomenon. So how you're going to do this, you're going to complete the phase change simulation along with your phase change notes. This will help you start gaining the understanding of why. Then when we meet again during our phase change group lesson, you guys are going to be acting out as molecules, and we again will try to make this an event that you guys can remember, and hopefully it makes it a little bit more concrete, because it is a really, really weird idea, objective, and actually it's probably the most difficult of your entire unit. So please come in on whenever we meet for our phase change lesson. Make sure you have all of that stuff done, and make sure you come in with questions. Those questions will be answered during that lesson. All right, good luck.